Assalamualaikum. Good day, everyone. So this is example for shear wall design to Eurocode using Eurocode. It's quite a lengthy solution, so it will be divided into several parts of the video. Okay, you have to look the video part by part in order to get a full solution of this example. I'm going to make a short video, that's why it will be divided into several parts. So let's look at the question first. Figure below shows the position of shear wall for a 5-story building. So you have a 5-story building. So let's look at the figure. So this is the elevation view of your buildings, and this is the plan view. Okay. Walls 1 and 7 are 250 mm in thickness. So let's look at wall 1 and wall 7. So from this plan view, okay, you have a grid line from 1 to 7 and grid line A to D. Shear wall is located at grid line 1 here, and also grid line 7. Okay, and some of it is also located at grid line A and grid line D. Okay, however, since the wind load coming from this direction, so the shear wall that is effective to cater this wind load is the shear wall in grid line 1 and grid line 7. Okay, and this two shear wall at grid line 1 and 7, the thickness is 250 mm. In addition to providing vertical support to 175 mm solid slab at roof level and floors 1 to 4. So this means that the shear walls provide vertical support for the solid slab. Okay, you have a solid slab at roof level and also from floors 1 to 4. And the slab thickness, the thickness of the slab is 175 mm. They also provide lateral stability to the ground in the width direction of the building. So not only the shear wall provide vertical support to the slab, it also function as lateral stability, to provide lateral stability for the building. The walls are supported on strip foundation. So these walls or these buildings is supported by using a strip foundation at the ground, and the ground floor is a non-suspended slab. Given the following specification: the thickness of slab 175 mm, size of beam 250 mm in width and 600 mm in depth. Size of column, you have a square column 400 times 400 mm. Height of stump 1000 mm. Characteristic strength of concrete, your FCK, we will use 30 MPa. For the FYK characteristic, slightly spelling error here. Characteristic strength of steel, FYK 500 MPa or Newton per millimeter square. You have a nominal cover 30 mm, and wind pressure is 1 kilonewton per meter square. You have also been given this data of loading. So from finishes, ceiling and services, for the floor 1 to 4, the GK is 1.25 kilonewton per meter square. This finishes, ceiling and services falls under GK or permanent load. Okay, and roof, for the roof floor or roof level, you have the permanent load of 1.5 kilonewton per meter square. Next, we have a variable action QK, and for the floor from floor 1 to 4, you have a QK of 4 kilonewton per meter square. At roof level, you have 0.6 kilonewton per meter square, and last but not least, you have a partition of 0.8 kilonewton per meter square. And from this is from the elevation view. We can see that the height of each floor is 3.5 meter. Okay, you have the same height from the first floor to the fifth floor, and the height of the stump is not in the figure, but it is given in this slide, which is the height of the stump is 1000 mm or 1 meter. Okay, here. And this is the elevation view. Not elevation view, sorry, the plan view. Okay, so let's look at on the first step that you need to figure out, which is the action. What are the action involved in this example? So even in this step 1 action, okay, it is also quite lengthy, so the first part of this video will be on the action only. Okay, so let's look at we will use this data here to figure out the action. So let's look at on the solution. So first thing first, we need to figure out number 1 is action. Okay, as always, before we can start with the design, we must figure out the action, and the action given in the previous slide here. Okay, you can see that this is in kilonewton per meter square. It means that this is a floor slab, a floor load. Okay, kilonewton per meter square. Now you have action on slab. This is action on slab. Let's write it down as action on slab. Okay, and the unit is kilonewton per meter square. So what do we want to figure out here? First, let's divide it into the roof and also the floor loads, okay, or action. So let's look at on the roof first. Okay, so for the roof, given in the table previously, you have finishes, services, and ceiling here. Okay, at roof you have 1.5 kilonewton per meter square. So from the finishes and etc., you have 1.5 kilonewton per meter square. And next, this finishes and ceiling and services falls under permanent load, right? So one more thing that you need to consider here is the slab self-weight. It also falls under permanent load, GK. So we have slab self-weight. So how do we calculate the slab for the self-weight of a slab? Okay, and we want to get the unit in kilonewton per meter square. So you know that the unit weight of concrete or density of concrete, okay, it is equals to 25 kilonewton per meter cube. Okay, so if we want to figure out what is the self-weight for slab, we want it to be in unit kilonewton per meter square, right? So what should we do? From 25 kilonewton per meter cube to get in kilonewton per meter square for slab self-weight is to times with the thickness of the slab. Then you have a per meter square how much is the self-weight of the slab. So H time 25. Okay, 25 is not FCK, it is not characteristic strength of concrete, but it is the density, the unit weight of concrete. Okay, students always get confused with this value of unit weight of concrete here. Okay. All right. So the slab self weight from the question is 175 mm. So 0.175. Okay. This is in unit kilonewton per meter cube, right? Per meter. So your H should be in unit meter. So 0.175 times 25, so equals to 4.38 kilonewton per meter square. So this is your total GK. Okay. So your total GK is equals to 5.88 kilonewton per meter square. Okay, 1.5 plus 4.38, you get 5.88 kilonewton per meter square. So this is GK. How about QK? So let's look at here. You have variable action for roof 0.6 kilonewton per meter square. Right, so let's add that here. QK is equals to 0.6 kilonewton per meter square. Okay. We are not going to add this one because this is GK and this is QK. We cannot add it. We will add after we times with the safety factor later on. Okay. Alright. Now this is for the roof. Now how about for the floors? Okay. So you have floor from level 1 to level 4. Okay. So the same things here. Okay. Finishes, etc. And then the slab self weight and calculate the total GK and what is the QK. Let's do that. So first we have the finishes and etc. For the floors. Okay, for the floor, the finishes, ceiling and services is 1.25 kilonewton per meter square, and you have also this for floor. The variable action is 4 kilonewton per meter square, and this partition 0.8 kilonewton per meter square. So, for roof, we're not going to add partition load because we don't have partition in the roof. But for the floor 1 to 4, we can add this partition load. So let's do that. So firstly, the finishes and ceiling and services is 1.25 kilonewton per meter square, and also the slab self weight. Okay, the same thing. It is H times 25, where your H is 0.175 times 25. You will have the same value, which is 4.38 kilonewton per meter square. And then you have your, oops, what's that? Hey, what happened? Tak boleh padam pula. Not sure what happened. Okay, it's okay. Let's move this to let's go to the next slide. Let's go to the next slide. We need to total up this. Okay, you will have also the same thing, which is not the same thing, 5.63, because you have different loading for the finishes. Okay, you have a slightly less GK from the finishes, ceiling and services. So it end up with 5.63 kilonewton per meter square. Next, for the QK here, can I? Boleh pula tulis. Okay, QK is equals to, just now for the QK is 4 kilonewton per meter square plus your partition 0.8, and this will brings the total of your QK 4.8 kilonewton per meter square. This is not sure why. Kenapa tak boleh tulis total GK kat situ. Okay, not sure why I cannot write it down here. Alright, so basically this is for the roof and floor for GK and QK. You have one more action, which is the not one more action, one more element. Okay, besides the roof, the floor, one more element that you have is the wall itself. Okay, so this is roof, this is floor. Next, for the wall, okay, for the wall, what do we have? We have the self weight of the wall. So to get self weight of the wall, similar as the slab, we will times with the thickness of the wall times 25, the unit weight of concrete. Okay, so the thickness of this shear wall is 250 mm, so it is 0.25 times 25. This is equals to 6.25 kilonewton per meter square. Okay, next, we're not finished yet. For shear wall, we need to figure out action is loading. Okay, load action at the bottom of the wall. Here it is in unit kilonewton per meter. For action of the slab and also of the wall, that coming from the wall, it is in unit kilonewton per meter square. But now we want to figure out what is the action at the bottom of the shear wall in unit kilonewton per meter. So first, from previous slide, okay, you have the roof, you have the floor, and at each roof and floor you have the GK and you have the QK. So action at the bottom of the wall, first we will, let me change the color of the ink, GK. Let's look at on the GK, on the permanent load. Okay, you have the permanent load that coming from the roof, here the GK, the total GK 5.88. now the unit here is kilonewton per meter square. Okay, from the roof, imagine you have a load of 5.88 kilonewton per meter square, and we want to convert it into kilonewton per meter. How should we do it? Let's look at this figure here. Okay, let's say you have this this 555. Okay, the same. Okay, let's look at this figure here. So from kilonewton per meter square, you have this kilonewton per meter square. Okay, for example, just imagine here. So from kilonewton per meter square, what we want to find is only kilonewton per meter only here. Okay, so that means how from kilonewton per meter square here we want to convert it, we want to make it into kilonewton per meter. It means that what is the load, how much is the load that is carried by this wall, how much is the load that is carried by this wall from this slab. How do we normally do it? Okay, so the easiest way, not the easiest way, okay, so practically half of the load will be taken by this shear wall and another half of the load will be taken by this beam here. Okay, so we will consider only this half part of the slab here. Okay, so that means from kilonewton per meter cube, per meter square, you want it to be kilonewton per meter, you need to times with half of this 6 meter, half from 6 meter. Okay, it means that here the GK from the roof, okay, this is roof, and the GK from the roof 5.88 kilonewton per meter square, 5.88 kilonewton per meter square times 6/2. Okay, you know why 6. Okay, 6 is this dimension here, 6 meter, and y2 because we just take half of the slab. Okay, so this brings value of 17.64 kilonewton per meter. Next, for the floor. Floor means from level 1 to level 4. Okay. So for the floor here, the GK is 5.63 and the same concept. Okay, the same concept for the GK, we will times with half of the 6 meter. So 5.63 times 6/2. However, you have floor 4 floor of slab. Okay, level 1 to level 4. Okay, for roof you just have one roof, but for the floor you have 4 floors underneath, not underneath, okay, below this roof level. So times with 4. Okay, from this elevation view here. Okay. So equals to 67.56 kilonewton per meter. Okay. Next, on GK you also have the self weight of the wall. Self weight of the wall falls under GK juga. Okay, permanent action, right? So wall is equals to this 6.25 kilonewton per meter square. For wall, slightly different here. Okay, for wall, slightly different. What are the different? So instead of times with the 6/2 here, okay, this is for the slab, right? We are considering the slab just now, but for the wall here, okay, for the wall, kilonewton per meter square for the walls. Let's say wall 1. Okay, let's say you are at wall 1 here. Okay, let's say this is wall number 1. Everything here is wall number 1. Okay, let me highlight it. Okay, so let's say this is all this elevation view. Okay, please imagine that this is not a slab. Okay, not a slab, this is the wall. This is elevation view. Okay, please take note on that in your mind and try to imagine it. Okay, for slab, just now we take half of the slab dimension. Okay, but for apa ni, shear wall. Okay, so this is your shear wall. Okay, and kilonewton per meter, we are considering the loading at the bottom of the wall, right? So at the bottom of the wall here, we want to figure out. Okay, so what should we do? If this is half from the slab, then this means that you will use you will take half of the height of the building. Okay, the height of the building. So what is the height of the building? 5 times 3.5, you have 17.5, and also don't forget you have the stump here. Okay, let's change to in color. Okay, times with 17.5 plus the stump. Okay, this will brings you 115.63 kilonewton per meter. So please bear in mind, this is the height of the building. Okay. Oh, sorry, we are not dividing it with half. No, sorry, we're not dividing it in half. Okay. Lain ni, aku nak padam, lain dia padam. Okay, it's okay. Let's do it again. Okay. Doesn't make sense kalau if we divide it in half, because this part here, the roof floor, doesn't take the load from this wall, right? All of this wall, the height of the wall, okay, so all of this will be carried by this bottom of shear wall. So we need to times the height of the building here, 5 times 3.5. Okay, all right. Next is we want to total out what is the total of GK. Here it is 200.83 kilonewton per meter. Alright, so this is GK. Alright, for QK we are going to use the same technique, or not technique, okay, understanding. Alright, for roof, what is the QK of roof? For floors, what is the QK of floors? And wall, for walls there is no QK for walls, so for QK for the variable action you only have from roof and from the floors. Here for the roof, the QK is 0.6. For the floor, the QK is 4.8. Right, for QK. Okay, so you have roof equals to 0.6 times 6 over 2. You know by now what is 6 over 2, and y 6 over 2 kilonewton per meter. And for the floor, it is 4.8 now, right? 4.8 times 6 over 2 and times 4. Okay, from level 1 to level 4. So this will bring you 57.60 kilonewton per meter. And lastly, we have the total QK, (59.40 kilonewton per meter). Okay, and do we stop here? No, we have the wind action, the WK. So for the wind, WK wind action is equals to the safety fact, the value of wind action from the question. The wind pressure is given as here 1 kilonewton per meter square. Okay, and this 1 kilonewton per meter square acted where? It is acted at from this, okay, from this direction. So it means that this part of the building here, okay, this part of the buildings will subjected to the wind load. So we call it 2 times the loading after this. Sorry. So let's look at you have the wind pressure 1.0, right? This is in unit kilonewton per meter square, and we need to times with the surface area of building in the wind direction. So what is the surface area of the building in the wind direction? So here is the wind direction, and this is the surface area. So imagine this in a 3D view. Okay, so you have from so let's say this is your grid line 7, this is your grid line 1. Okay, this is your grid line D. Okay, so what are the surface area of this part here? So we know that this is how much? 1, 2, 3, 4, 5, 6. 6 times 6 is 36 meter, and the height of the building just now is 17.5 plus you have the stump 1.0 meter. So the surface area of the building is 36 times 18.5. This is the surface area of the building. So this is equals to 1.0 times 36 times 18.5. Okay, you know how do we get 18.5 here, right? So this is equals to 666 kilonewton per meter. This is how much the action that come from this wind action. But this is for the whole building. Your building here in this direction, you have the shear wall at grid line 7 and also at grid line 1. Okay, so we are going to divide the loading by these two walls. Half of it will be taken by wall 1 and half of it will be taken by wall 7. So wind action on wall 1 will be equals to the wind action at wall 2, okay, or wall 7 lah. Let me write that as 7, wall 1 and wall 7. Okay, so this is equals to 666 kilonewton per meter. Divide by 2, you will get 333 kilonewton per meter. Alright, so you have here the WK, okay, you have the QK, and you also have the GK. Okay, so this is the first part of the action, step 1. Baru step 1, we just at step number 1. Okay, we figure out how much is the total GK at the bottom of the wall. At the bottom of the wall, the total GK is 200.83 kilonewton per meter. The QK is 59.4 kilonewton per meter, and the WK is 333 kilonewton per meter. Alright, so that's all for this video. For part 2, the next video, we are going to look at the in-plane action and transverse action. Okay, so we are not done yet with the action. Okay, we just figure out what is the action at the bottom of the shear wall. Next, we want to figure out what is the in-plane action and what is the transverse action. Okay, so I'll see you at the next part, video number 2. Alright, see you everyone, have a good day.